So, out of all the questions on the homework, which one or ones are you most entertained by or not entertained by? There's a few that you can't do flat out. Can't do 25. You can get pretty far. You can get really far on 28. Let's get really far on 28. You can get really far on 28 without actually finishing it. That's what I was interested in seeing on 28. So on 28, what's the first step? You're trying to find what? The inverse. So what's step 1? What do I like you to do first? Yeah, so I like x is equal to 1 plus e to the y over 1 minus e to the y. What's your goal now? What's your goal? Yeah, we want to solve, I want to isolate y. Exactly. Okay. So what do we need to do first? What's our first step? Someone raise their hand and tell me what mathematically, what operation should I do first? Slalom. Yeah, you multiply both sides by that, and you end up with this. Step 2, who wants to raise their hand and tell me what should I do now? No one knows what I should do now? We did this 3 times Friday. What's it called, Pang? Distribute? Yeah, x minus x e to the y is equal to 1 plus e to the y. We haven't done anything new yet. Still in precalculus land. What now? Again, our goal is to isolate y, so what do we need to do? Get all y's on one side. Yeah, let's make it x minus 1 is equal to x e to the y plus e to the... Now what? Now what? What's my favorite thing in all of math? You guys know what my favorite thing in all of math is. Let's factor. We're factoring out what? E to the y. Yeah, factor out e to the y. So we have x minus 1 is equal to e to the y times... Now what? Plus 1. So e to the y is equal to x minus 1 over... That's really, really far. That's 90% of the work. The next topic, logarithms and exponents, will help you finish that. But if you got that far, that's what you could do. That's what you could do. Nothing would have changed right there. If that e to the y was just y, you would have done the exact same work. If you need to finish it, and you had the ability to, this turns into log base e of x minus 1 over x plus 1 is equal to y, which is ln of x minus 1 over x plus 1. You learn about logarithms in the next unit. Logarithms help you solve exponential equations, and exponential equations help you solve logarithms. They have multiple uses. That's just one of their uses, but that's how they're going to be introduced. This right here, you don't know how to do yet. Some of you may have seen it before. But does that allow you to finish? It does. It does. 25. Let's see here. 25. Nope, can't do it. Try again. What next? 27? Nope, can't do it. Come on. What? 30. I like 30. Thank you. 30. 30 is one you can actually do. Yay! And it's a really good question. I love this question. This is a great one. So they're asking you to find the explicit formula of the inverse, meaning you have to isolate y. When they say explicit, y equals something in terms of x. Just y in terms of x. So first of all, you notice the domain. So if we graph this to start out with, if we graph this sucker, there it is. And what else did I graph in there? I graphed y equals x. So you have an idea of what this looks like. And also it asks you to make the graph, doesn't it? Yeah. So if you actually do this, there, it matches. Now, I have a question for you. If I graph this, you'll notice in the y equals on here, do you see the x greater than 0? That limits the domain. If I go over and I delete this, if I delete x, did anybody just graph this and see what it looked like on their calculator? If I graph that right there, I'm going to do zoom standard. There's a whole other part of it when x is less than -1. But this graph you only want the domain you only want the x values that are greater than 0. So what you do is you go back into y equals, you go all the way over to the right of this. You don't put any operation in it. You go all the way over to the right, parenthesis, x, and if you do second math, go down to greater than, and you plug in x greater than 0 in parentheses, and that will limit the domain to just being greater than 0. I don't really care about y equals, because it's whatever it's symmetric over. So I'm going to change this window back. I'm going to go from 0 to 4, and I'm going to make the y values from 0 to 4, and I go graph. We go back to this original graph. Now, if you have this graph, what can you sketch pretty nicely now?
Inverse.
You could sketch the inverse. So you want something, you know the inverse is going to look something like that, and it will be a function. So, what do you do first? What's our first step? Switch. So we end up with x equals the square root of. I don't like square roots, so what am I going to do? And just because I like putting things on the left side that I'm solving for, I end up with y squared plus 2y equals. And you tried to solve for x, didn't you? What's the problem? What wall did you run into? Yeah, but you have an x, you have y's with two different y's with two different powers. Does that nicely factor? No. This essentially is what kind of function? What kind of function is that? If you're solving for y, if you're just looking at it in terms of y, what kind of function is that? What's the highest power of y? It's a quadratic. When you see quadratics, what do you generally try to do? And if it's not nicely factorable, what do you use? To use the quadratic formula, what do you need it to equal? Y squared plus 2y minus x squared is equal to 0. What does our a value equal? What's our b value? What's our c value? Negative x squared. We are treating x as a constant, and we're solving for y. We are trying to isolate y. What does x do? What does the quadratic formula essentially do? It solves for x. It isolates what? It isolates x. That's all we're really doing here. So can you actually cheat this out a little bit? Absolutely. Now, do you just plug this in straight to the quadratic formula? No. You do the discriminant, which is b squared minus, what's b? So 2 squared minus 4 times 1 times, so what does this equal? 4 minus, or 4 plus what? So we end up, we're solving for y, so y equals plus or minus, what? What's b? Oh, sorry, what is b? Negative 2 plus or minus the square root of what? What goes underneath the square root sign? All over 2. And we're going to keep working with that in a second, but go to lunch.
What could we first do to simplify this? Any ideas? Well, let's look in here. What can you factor that into? Yeah. 4 times 1 plus all over. Well, that's negative 2 plus or minus the square root of 4 times the square root of what? All over 2. 1 plus x squared. What's the square root of 4? All over 2. What can we factor out of the top? 2. Negative 1 plus or minus the square root of 1 plus x squared all over, what cancels? So you're left with negative 1 plus or minus the square root of 1 plus x squared. Okay, so there's plus or minus there. But this is we've come up with this domain. We need to figure out if it's just the positive or just the negative, because with plus or minus it would not be a. If I graph that with plus and minus, it would not be a what? It would be an equation. It wouldn't be a function. It wouldn't be a function, right? Let's go back. What does it tell us that this is the domain, right? So that means it's telling us that the domain is x greater than 0. What does that tell us about the inverse? The range is what? Y such that? 0, exactly. So y has to be greater than 0. So let's look at this for a second. If you square a number, the result is always going to be? It's always going to be positive, right? 1 plus a positive number is always going to be? So this right here is always going to be? What's the smallest value x squared can be? What's the smallest value 1 plus x squared can be? So what's the smallest value this whole thing can be? So therefore we know that for this one, it'll always be, so the, excuse me, we already knew that the range was greater than 0. That verifies it for us, correct? So we want to make sure, we know the output is always greater than 0, but we want to make sure that the input matches. So we can draw a picture here. In terms of the picture here, what's the domain and range of this inverse function? Well, we know x is greater than 0, and also y has to be greater than 0. So we already knew that y has to be greater than 0. So down here, what do we have to say? What's the domain have to be? If we don't specify that, I mean, are we allowed to plug in a negative x value into this? Could we plug in a negative x value? Yeah, you could. But if you plug in a negative x value, the graph is going to do something on this side. Does that match a reflection of this? No, it does not. It really doesn't. It doesn't with this domain restriction. So what does that mean here? We have to pick which one we're talking about here. Positive plus or minus is what I'm focusing in on here, ever so not eloquently. You agree that that is always positive, right? What's negative 1 minus a positive number? Yeah, so always what? Always what? Negative 1 minus a positive number is always what? Always negative, right? But we want the range to be positive. So which one are we going to choose, minus or plus? Choose plus, since negative 1 minus the square root of 1 plus x squared will always be, and we want, so our inverse is therefore going to be, what do we think our inverse is? Negative 1, yep. Exactly. So that's what we think it is. How can we check that visually? We can graph it. So we think it's going to be negative 1 plus the square root of what? 1 plus x squared. Does that match? Sure looks like it. If we extend the window, though, if we go from negative 4 on, what are we going to see? Well, there's the original function. Here's y equals x. But what are we going to... Oh, there's this extra piece right here. See that extra piece? What do we need to add on to the end of y equals down here on y3? Yes. X is... You go all the way over here. X second... Not matrix, sorry. Y equals... Now I got to go back down again. Oops. You did an x is, so second math greater than 0. And now when I graph this, should you see that little left thing? No, it should be gone. Zoop. There's the original function. There's y equals x, and there's our inverse function. Does it look pretty good? Yes, it does. So let's clip this in and we're all set. So without the domain restrictions, are the inverses correct? No. What do you have to add in? So we know that that is f of x. That right there is f inverse of x. And what's that? Y equals x. Now visually, does it look pretty good? Yes. What happens if 1 point was off? Let's say 1 point was over here. Would it be an inverse? No. So is there any way to test all points? How many points are on just from here to here? Are there any way to directly test all the points? Is there any way to directly... No, there is not. Are there other methods that can prove conclusively if it's an inverse? Yes. Are we going to learn that now? Well, not right now, but maybe tomorrow. But visually, are you pretty confident that that's the proper inverse? Looks pretty good. Looks pretty good. Absolutely. Are those inverse functions? Yep. Are they one-to-one? Yep, they're both strictly increasing. Very good. We made our table. It's definitely going to, we know it's going to start a little bit to the left of 1. But then what's it do? It goes to 1, goes to 1/3, it goes to 1/4, it goes to... So what's this thing going to look like? It's going to get closer and closer here. It goes back a little tiny bit up here, right? Little tiny bit. Oh, is there an arrow on it? I'm sorry, that's a mistake, right? Is there supposed to be an arrow? No. It stops
It stops wherever f of x stops, right? It stops, f stops right there, so I need to actually, what do I need to do here? I need to erase a little bit, don't I? Need to erase this, 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 and it needs to stop. Where am I stopping it? At the same place that f stops. Now, why did they have you graph 1 over x and the inverse on the same one? What's the point of having you graph both? What's a common mistake? Yeah, is f inverse the same as, that's 1 over f of x, right? Is f inverse the same? Not always. Can it be? It is possible for it to be. It is possible, but is it always going to be? No, most of the time it's not. So this gives you a very conclusively, tabular, with data and graphically, inverse and 1 over f, are they generally the same? No. Can they be? Yeah. For example, functions that are inverses of themselves, y equals x. Actually, that's a poor example. Where is the inverse equal to 1 over the number? I have to think about that for a second. I'm blanking. I should have the answer to that.